the point is, maps have always given a lot of information in a short amount of space and time, and that's why maps have always been compelling. It's very rare to find someone that actually hates maps, and hopefully none of you hate maps. And if you did at the beginning of the workshop, maybe you'd say, well, okay, maybe I see the value of them now. Maybe I wasn't all that keen on them, but now Joseph hopefully has got me really excited about all this. But that's the same kind of power and intrigue that maps have had in the paper age, I think even more so in the digital age, because now at your fingertips, you've got this at your fingertips, and we haven't even signed into anything. You have this same tool on your own device, on your laptop, on your tablet, even I suppose on a big phone, although you're kind of limited on the real estate on your phone, if you know what I mean. So it's nice to have a tablet or a laptop for this. But right away we can see things. Okay, well, what about this? I can say, well, gosh, wouldn't it be great if I could go back to the default view. So I'm just going to go ahead and refresh here. But if I said, wouldn't it be grand if I could search for another place around the planet? And that is, let's go over to England. Let's go over to Eastbourne. One of my favorite landscapes, place I've been to a couple times in my work travels, is this place over at Beachy Head. Okay, Beachy Head. So Beachy Head is one of those wonderful chalk cliffs. Maybe some of you have been there. Who's been to the chalk cliffs of England? Anybody?
No.
Okay, you've seen pictures though. And look at this. We're going to zoom in on this visitor center. And even at this scale, we can see that there was a row house right in the center of this image. There was a row house, and now you can see that the cliff has retreated by 2022, and so half of that row house is actually gone. It's been swallowed up by the English Channel. And this visitor center that I visited on one of my work travels, it actually has lines through the middle of the visitor center saying, okay, by 2040, it's going to be in the visitor center. By 2050, it's going to be on the north side of the visitor center, and by 2060, the visitor center is going to be gone. So coastal erosion. Okay, so again, thinking about processes on our Earth's surface and under and over the Earth's surface as well. A lot of those things we touched on earlier, but one of them is coastal erosion. So, okay, that said, it's a natural process. Is that being exacerbated by human influence at all? Let's look at some other coastlines of the world where we've built jetties, and sometimes those cause more coastal erosion and so on. So it's a natural process, but sometimes we accelerate it and sometimes we decelerate it based on, okay, we're going to dump a big pile of rocks here and prevent some more coastal erosion from happening. But this is a very dynamic landscape. It's a very beautiful landscape. If you have a chance, go over there. Let's take a look at another issue. Let's look at Saudi Arabia. So this is going to be similar to those of you that have flown across the central U.S. We were just looking at southwest Kansas. But in central Saudi Arabia, they've got the same kind of thing, those center pivot irrigations, right, with the center pivot irrigators that rotate in a circle. And as you can see here, I'm going to change the dates over here a little bit. Now we've got basically 6 years of imagery at our fingertips. And you can see here that over in this side of the image, you can see some of the imagery from some of the imagery that this is actually the number of center pivots has expanded. Okay, you can see sort of this part of the image, northwest side of it. You had a few in 2014, and then by 2020, 2022-ish, you had more. Same kind of thing we have in Kansas and Nebraska and here in Colorado, especially in eastern Colorado. But okay, where's the water coming from for those center pivots? It's being mined from the underground aquifer. So the question, that you and I have, right, is what's it going to be like in 10 years? How long is that aquifer going to last? It's not a replenishing thing. There's not enough. It's even more critical than the Ogallala aquifer. There's not a mountain range really that's feeding this. Yeah, there's some mountains, as you know, from being geo people, right, over in this part of Saudi Arabia, in the southwest part of the country. There's some mountains there, but it's not like the Rockies. These mountains do not get as much precipitation as the Rockies do, and so hence the this whole thing here is even more tenuous than the Great Plains of the U.S. This is, and notice if I zoom even in farther, notice just to the north of this, we got what are these ripples? What are these things? Like these, there's tannish colored
sand, aren't they?
Sand dunes. Yeah. So, you can get real tight in here and see that, okay, well, they've built a center pivot here, but they've had to level out the dunes there. And then how much of the dunes are actually going to maybe encroach on some of these these farmsteads. And again, thinking about the whole, okay, we're 7.5 billion humans. We've got to have crops. And where are they going to grow them in Saudi Arabia? They've got to irrigate them if they actually want to be sort of semi-independent for food production. So they've got this situation going on. They also have desalination plants and so on and so forth. But the point is that those are not able to supply all of these farms with water. So they're mostly for domestic use, as you probably know. Anyway, with this one tool, you've got, oh my gosh, you've got human influence. You've got how about the Three Gorges Dam? Wow, we should be able to see massive amounts of change there, shouldn't we? So if we go to 2014 and 2021, let's take a look here with, okay, 2021, you've got a lot of, as you probably have read, a lot of communities upstream that have flooded. I mean, thousands and thousands of people had to be evacuated, right? To hold that water, they had to relocate massive amounts of people. So in 2014, and at this scale anyway, the dam is not even completed yet. Notice here, you've got the river flowing through here. But by 2022, the dam is there, and then you've got this huge reservoir that's filling up for power production and other things. So interesting, lots of human modification of the landscape. And so with the same tool, you can look at glacial changes, urbanization, even here in Denver, even your own neighborhood. So let's go on to the neighborhood level. Feel free to put your own neighborhood in there. But I'm going to put our ESRI building. Okay, so I'm now extremely local. And you see here that in 2014, just to the north of our building, which is right in the center of this image, we had actually a fairly lovely view of all the way up to Fort Collins almost. So we could see Longmont, Loveland, almost up to the Horsetooth Reservoir up in Fort Collins. And then this was put in, this big apartment complex. So everybody on the north side of the building now is looking at the apartment complex and no longer had that big view. We have a view out to the west still, but you can see that even on the local level, right, things have changed. And so again, thinking about what's changed, why is it changed, and so on. You can see lots of changes just in your own neighborhood, or your mom's house, or your kid's house, or you know what I mean? You've got lots of tech capability, and it's a global data set, as we've talked about. We looked at England, we looked at Saudi Arabia, we looked at China. This is the way back imagery from that living atlas of the world. So literally at your fingertips, you have literally terabyte loads of satellite imagery right at your fingertips. Fascinating. I just think this is a fascinating tool, not just for general exploration, but a teaching tool. So if you know educators and you want to teach about, they're teaching about change over space and time, which a lot of educators teach, environmental science, geography, even economics. We talk about the center pivot irrigation. They want to look at change over space and time. And of course, outside of education, it's an incredibly valuable tool for people planning cities, parks, sustainable agriculture, et cetera. So this kind of thing is part of this whole modern geographic information systems that we talked about last time. Questions, comments about any of that so far? Hopefully you're saying, ooh, I want to explore some more, Joseph. Well, that's where, after the workshop ends, you've got all these capabilities at your fingertips. You can watch the recording if you need some guidance and some tips. But basically, as you can see here with this particular tool, it's just a matter of me going to the swipe mode on the left side. And also the thing that I probably should show as well, toggle animate mode. If we do that, it's going to load all the images that are available for that particular location. And you can see now that it's going to basically play you a little movie and looking at change over, in this case, from 2014 to 2022. Now, that's fascinating too. So that's another nice capability with this, and not just the swipe, but the animation. Hopefully you're seeing that little movie being played. And of course, you could do this for any place on the planet. Now, you may wonder, hey, Joseph, I'm interested in looking at imagery further back in time, or maps further back in time. We'll explore that here in a moment. Images, 1974, really, 73, 74 was the first Landsat set of pictures that were rigorously and thoroughly and systematically taken of different locations on the planet. That was a joint venture between the people I used to work for, U.S. Geological Survey, and NASA. So at the time, think of, the early 70s, lots of lunar launches. And a lot of people in the scientific community said, hey, this is all good to be exploring the moon, but we really need some better understanding of our Earth too. So let's have a satellite that's just dedicated to taking images of the Earth's surface and in different parts of the electromagnetic spectrum. Color infrared, and some things that your eyes can't see, but they're very useful to look at. We have the Landsat satellite, and time doesn't permit us to actually look at the Landsat data, but realize that you've got 50 years of Landsat imagery, and one of the Living Atlas apps is actually, let me just at least show you where it is, but you've got this Landsat Explorer app sort of south central in that list of tiles. That Landsat Explorer app, and feel free to go through that on your own, it gives you the 50 years worth of Landsat imagery. Landsat imagery, again, is not just in the visible part of the spectrum. It covers parts that your eyes cannot see. Why? Because, for example, if you take a look at healthy vegetation in near infrared, it shows as bright red. Whereas in the visible part of the spectrum, do I know if that vegetation is actually healthy or not? What if I want to figure out where the pine beetle infestation is here in Colorado or elsewhere? With the Landsat imagery, you can pick out the healthy vegetation versus vegetation that's in trouble, and among other things that you can look at in the other parts of the electromagnetic spectrum. As you probably remember from science classes, some of you actually are or were or still are scientists. You're in the science community. You know that our eyes can only see a fraction of the amount of energy out there, right? Microwaves, X-rays, ultraviolet, infrared. I mean, we can't see that part. We know it's there. We can only see radio waves. We can only see a little bit. But the Landsat imagery has a camera that takes images at different parts of the electromagnetic spectrum. So that Landsat imagery goes back in time for about 50 years. But also realize this, the sensors on those Landsat, and then why I say those is because there have been several iterations. They don't last more than 10 or 15 years. One of them's lasted about 20 years. But Landsat 8 went up. Landsat 8 went up, I think, last September, I believe it was. There's been a set of Landsat satellites, but they're not as high resolution as the ones in the visible spectrum that we looked at a moment ago in the Wayback imagery. So you're going to get 30 meter pixels, 15 at the very most, the very highest resolution. So you're not going to be able to pick out, your house or that apartment complex. You're going to get pixels at that scale. It's going to be fuzzy. So, but still, for regional studies, especially looking at, we looked at river systems, droughts, mountain ranges, etc. It's going to be very useful, and it goes further back in time. Another one that does go back in time that we will have a chance to look at is this USGS historical topo map viewer, which is one of my all-time favorites, in part because I used to work at USGS and I love to go hiking. And I think we had a little poll last time, and a lot of you go hiking and you love topographic maps as well. But this Topographic Map Explorer, which again is one of those Living Atlas apps, it has a default view, like all maps have, that starts, in this case, as you can see, New Orleans. But what if I wanted to look at another place? What if I wanted to look at Morrison, Colorado on the west end of Denver? So this has a different look and feel to it, but most of these apps are actually pretty intuitive. You just have to spend a little time. Usually there's a tutorial that guides you through how do you work it. But in this case, I'm going to pan to the north a little bit. And I'm going to click on basically the place where I-70 goes into the mountains west of Denver. I know all of you have seen the hogback and you've seen the cut there at Morrison. So, okay, on the bottom here, I've got a timeline. And the timeline in this case is when the topographic maps were actually published. So if I go back here, I can see the scale on the left side too. Ooh, here's a Morrison 1938 1 to 24,000 scale. I'm going to go ahead and click on that. If I click on that, and notice I've got a transparency tool. So I can go from fully transparent to opaque, the opaque giving me the 1938 view. And if I go to 1938, I just love this, folks. I wish I could get excited about this. This is so awesome. You know what I'm going to do? I'm going to do there, I've got rid of my bookmarks, so you've got more real estate to see, but in my browser. But notice here, when you were in 1938, motoring with your, the car that you had back that you may have had back then, or maybe your mom or your grandparents or somebody, you're going along, west of Golden. You have to go by Heritage Square for some of you that knew where that was. And then you're along the hogback, and then you had to turn up Mount Vernon Canyon to get up into the mountains. So that was the route out of Denver. And then, of course, years later, you got I-70 that went right through the hogback because it was too steep of a grade, and also those curves would have been too high or too severe for the high speeds on I-70. So they had to smooth it out, and they blazed right through the hogback, which is actually kind of interesting because now we've got those layers that you can go stop and look at. But the point is, that's exactly what it looked like back in 1938, according to the topo map that we've got at our fingertips. Now let's take a look at, what about 1958? Look what I've got at my fingertips. I've got a lot of interesting stuff. 1970, let's take a look at that. So now I've got the 1971 map, and notice in 1971 you had some of this purple tint in here. So you've got some Lakewood sort of suburbanization happening in 1971, which of course now goes right up to the base of Green Mountain on basically the east and the north sides of Green Mountain. But in 1971, it was just starting to come out that way, and you had a little bit of urban tint coming out there with this purple color, and I-70 being purple also because it was relatively new back in 1971 out there. So anyway, the point is, again, you've got a lot of information at your fingertips. Let's take a look. Let's zoom out a little bit. Red Rocks Park was there, right, in 1938 because that's a public works project from the Depression. So we can go there and see, what did it look like at Red Rocks Park? Here's what it looks like now. 1971, as you probably remember, maybe some of you that have been around in Denver for a while, you used to be able to drive across the hogback until they closed off Dinosaur Ridge for foot traffic about maybe 15 years ago. So you used to be able to drive across that. And in 1938, I'm going to turn that on. Look, there it is. So there's Red Rocks, fairly new back in 1938 with the road network and so on. Maybe the amphitheater was built then. I'm not quite sure when the amphitheater went in. But anyway, you got this amazing set of information at your fingertips. Just for fun, I'm going to pan to the northeast here into Lakewood in 1938. There's West Alameda, and there were absolutely no houses. And I don't even see any dark symbols indicating if there was a ranch even up there. But it's interesting, right? You were swinging around the south side of Green Mountain, and you could do this for anywhere, right? So your house, I'm going to go to Denver now, and I'm going to go to the airport, okay? So, you've got a topo map called Box Elder School. That was actually the name of the zone where the airport is now. And if we look here, we've got, let's take a look at that, Box Elder School. Okay, so this is what the airport looked like. What was the date of that map? 1966. Here's Pena Boulevard, right? This is what it looked like. There were a few ranches out there. Look, there's a couple of ranch houses and so on. And of course, now it's the airport. So if I make this opaque, you can see what it looks like now. Radical change, right? Massive amounts of change. But we could look at, what about in 1981? What did it look like then? And so on. There was a couple more roads out there by the 1980s. But anyway, fascinating to be able to do this for any place. Now, this is a USGS Topographic Map Explorer. So unlike the Wayback Imagery, this is only the U.S. Now, you may say, hey, Joseph, aren't there historical maps of England from the Ordnance Survey that go way back into the 19th century? Yes. It's a different mapping tool that allows you to look at those. Ditto for historical maps of, China, Australia. Good on you, mates. She'll be right, etc. Okay, but this is just the USGS Topo Map Explorer, so it's only U.S., but still, you've got 100 years of topo maps at your fingertips. Now, maybe like me, you've got a bunch of USGS topo maps and other maps in your house. I suspect so, because probably otherwise you wouldn't be taking this course. So, in full disclosure, I have a bunch of maps at home and a bunch of maps at work. How many of you do?
Sure.
Okay. We talked about some of our maps, our favorite maps last time, didn't we? They take up room. I've had to, sadly, whittle down some of my map collection over the years because I simply don't have room for all this stuff. The nice thing about things like the Topo Map Explorer is that you actually don't have to have drawers full of these big topo maps, right? Even a 7.5-minute topo map, which covers 7.5 minutes of latitude and 7.5 minutes of longitude. We could talk about why it's called minutes in a bit if you'd like, but it covers a chunk of Earth's surface, 9 miles by 15 miles-ish. So 54 square miles or so of the Earth's surface. You've got a lot of those. You don't really have to have all those in your physical possession, although I do realize there's some value in actually having that paper map at your fingertips. But the point is, I was able to get rid of some of my old historical maps when this tool came online, because I'm like, do I really need drawers full? They take a lot of room to store. But anyway, it's nice to be able to have this, not just for us to explore, but again, as a teaching tool, as a landscape change analysis tool, and other things that people want to look at. Hey, what was it like back then? And what is it like now? And how can we plan for a more sustainable future with these tools at our fingertips? Where has the river coursed in the past? Can that help me figure out potential floods if I knew where the river actually ran in the past, that kind of thing? So especially since we've modified so many of our rivers, right, folks? Anyway, the point is, you do have, wow, look at this. Yeah, that's just amazing. You do have a lot of these tools at your fingertips, including the ones we've looked at. The historical wayback imagery, we've got the satellite imagery for the globe, the USGS Topo Map Explorer, and then the first one we started with was the Drought Aware app. Questions, comments, issues?
So far, so good. Love it.
Oh, you folks are just the absolute best. If you want a place to start, I oftentimes start with this indicators of the planet, because if I start with the indicators of the planet, it gives me a little tile for every one of those 21st century major issues that we talked about earlier. So as this kind of comes in, you see there's a little tile for wildfires. So if you go to the wildfires tab, it says, hey, what's going on right now? Again, thinking about that real-time data we talked about earlier. And every one of these issues that you see here, this is sort of like a monitor of what's going on the planet. Sure, with selected indicators, not every single indicator, but selected indicators. Remember last week we looked at hurricanes, so there's one on current weather and severe storms. But if I clicked on wildfire, which I'm tempted to do, but because of limited time I won't, you can go there on your own. But you'll as you probably would expect, the current wildfire perimeters as measured by various sources, but as fed into a live interactive web map. Okay, so wildfires and other issues. So this is a nice thing to actually start with in terms of, hey, I'm curious about the world. I'm a lifelong learner. That's why I love the Academy for Lifelong Learning. And so this is a nice place to start, the indicators of the planet. And this kind of touches on what I was indicating earlier in our first session, and that is these Geographic Information Systems tools, or GIS tools, are sort of like the nervous system in your body. Your nervous system, you don't really think about that much, but without it, we wouldn't be here, right? It's monitoring all of the vital organs in your body. And so mapping tools and geographic information is gradually, rather rapidly actually, moving us toward this sense of being a sort of a nervous system of planet Earth. It helps us to monitor, it helps us to plan, it helps us to figure out what's going on so we can, again, be able to save people's lives and property more efficiently, but also, again, planning for the future. So that's what these tools allow us to do, and I think that nervous system analogy is something that might be useful for you to keep in mind. Okay, all right, we are about 53 minutes into our session, so just like last week, we gave you a little break. And actually last week you all came back, which was very heartwarming to Marianne and I. So I'm hoping that if we do that again, you won't say, well, I've got more important things to do. I know you have busy lives and you're wonderful people, but please come back because we do have very wonderful things to close with in the last hour. So Marianne, you're the chief, you're the El Jefe, you're the boss. What do you want to do in terms of when do you want people to come back?
So we're at 1:54. How about 2 o'clock? And I'll press pause and we'll see you in just a few minutes.
Very good.
Thanks, folks. Good to have you aboard.